Who's seen that movie where the kid says, "I see dead people," right? The Sixth Sense. Okay, well, I see bad charts, and I see bad charts everywhere. And it's my goal in this session to give you guys a sixth sense for detecting bad charts. So if you develop that sense, then you're able to protect yourself against committing the sin of creating a bad chart. So how are we going to get there? We're going to get there by giving you the 4 keys to telling a good story with data. Over the last couple of years, over the last 5 years, we've seen predictive analytics come up as the hot new thing, and machine learning. And my team, we solve machine learning and predictive analytics problems for our clients. But the missing link that I always see is just being able to take what the data is saying and convert it into something consumable by upper management. And often management and the data scientists are speaking a different language, right? So I started to think critically about what is the theory around telling a good story with data? What are best practices, and what does the science say? So that's where we're going over the next 45 minutes. So in order to tell a great story with data, the first thing we need is to understand the audience. Who are they, and what do they need to know? We call the audience the hero of your data story. All stories need a hero, and for a data story, it's the audience, because the audience will determine what data you use, what metrics you use, and what charts and narrative you use as well. So very early on in my design process, I want to figure out who is my audience and what do they need to know. Once I've decided on my audience, then I'm ready to decide, well, what data is going to inform the questions or answers for this audience. And so this is often the most time-consuming part of the whole design process, because data is not always well-behaved. There's outliers and blanks and duplicates and data breaks and all sorts of problems that we need to deal with. Sometimes we need to link data from disparate sources to create the final data set we're going to use to tell our story. So getting the data ready is about 60 to 70% of where I spend my time. And it's not fun, right? But it's a necessary step. Now, once we've got the data ready, then we've got to decide what is the right metric for my audience. Are we going to use minimums, maximums, means, medians, modes? What metric are we going to use? A lot of data scientists like to use more complicated metrics, and often that's just not the right move when presenting to management. Okay, so we've got to decide on the right metrics for our audience. Now, once we've got the data ready, then we're ready to move on to the exciting stuff. Then we're ready to move to the visuals. But before we jump the gun and start selecting our charts, we've got to decide, is a chart even appropriate? Sometimes a table will outperform a chart. Sometimes what we call an impact metric will outperform a chart as well. So we've got to decide if a chart is appropriate. And if we've decided that a chart is appropriate, then we need a methodology for chart selection. Should we choose a line chart or a bar chart? A stacked bar chart or a dual axis line chart? Okay, so we need some sort of science to guide us in our decision making here. Now, once we've decided on the right chart, let's say a line chart, then we need to know, well, what does the science say about what a good line chart looks like? Where should the y-axis begin and end? How should it be colored? Okay, so we're going to talk about some of what the science says in this session. Now, these 3 keys here are where most analysts kick their feet up and say, I'm done. And out there in the wild, I see these decks full of charts and graphs that are just chart after chart after table after chart without much added value, without a real story. And so what we need to do to really tell stories with data is we have to layer the narrative on top, engaging language that weaves it all together. Okay? So my lofty goal is that in the next 40 minutes, I can give you a little bit of each of these keys so that when you go back to your own data sets, you'll be able to tell amazing stories. All right, so let's get going. We're going to start with the audience. I see a lot of charts like this out in the wild. Okay, what we have here, well, I don't see this specific chart type. This is a slope graph, which is not a very commonly used chart. It is great for comparing a numerical measurement at 2 points in time. So I don't see too many slope graphs in the wild, but what I do see in the wild are these boring titles. And I don't know what the education system is like here in Singapore, but in Australia at least, where I grew up, my statistics lecturers at university said the title of your chart should describe whatever the data is. Okay, so what we have here is 2015 and 2017 staff headcount. We're looking at the change over time, and it's broken down by department. So that's what the title is. Okay, but that's completely boring. That's not telling a story at all. So to tell a story with this, we've got to decide who is our audience. If I'm presenting to the head of sales, then I'm going to choose a headline appropriate for the head of sales. If I'm presenting to the CEO, well, maybe I'm going to pick out the biggest changes. So let's say I'm presenting to the CEO. Then I might actually present this data in this way. I'm going to highlight marketing because that grew the fastest. And then the IT team lost staff. And notice that I've been selective with colors. See, Excel, I pretty much blame Excel for the proliferation of bad charts throughout humanity. Excel thinks, and most BI software does this, they think that everything deserves color. And that's simply not true. So when I go through my design process, this is for static visualizations, not interactive visualizations, but for static visuals that are going to live in a PowerPoint deck, I actually gray everything out by default. And then I decide what deserves color and why. And that depends on my audience. Okay? Let's look at one more example of focusing on the big takeaway for our audience. I'm in a new relationship right now, and inevitably when you enter a new relationship, you get to a point where your partner asks you about your previous partners. And I said, what sort of data scientist would I be if I did not explain my previous relationships without a chart? So I've created a cascade chart here, which is really just a bar chart where the width of the bars has been scaled proportional to some continuous measure. So I've scaled the widths of the bars relate to how long was each respective relationship. But the problem is I've followed my statistics lecturer's advice in the title again. Intensity of relationship versus age. What a boring title. And it's actually obvious from the y-axis label and the x-axis label that that's what this chart shows. So it's a bit redundant to say it again in the title. So if I was presenting this to my partner, the big takeaway needs to go on top. Okay, now, the big takeaway when presenting to my current girlfriend is going to be different to the big takeaway when presenting to someone else, right? But for my current girlfriend, I'm going to say, my relationships have increased in intensity and length over time. That's the general trend that we're seeing here. Okay, that's making her feel good that she's kind of, at the top of the trend. Okay, but she's obviously going to ask questions about the time I almost got married. So I'm going to highlight that. Whilst Christina almost scared me away from marriage for good, I'm ready to commit again, just to reassure her. Okay? So let's get those big takeaways in our title. And yes?
I'm not sure about the person whom you are talking about, but why she'll not comment about Brazil? Because that's like...
True, and in many cases you do want to highlight the outliers. So if I was to redesign this again, perhaps I'd have an insight hovering here in the white space to talk about Brazil. But I actually kind of wanted to skip over Brazil when talking to my girlfriend, actually.
The person who is looking at the graph is...
They're gonna notice, yeah. Yeah, I might have to take a log transform of that, part. Okay, good observation. All right, let's move on. So, the last slide I'm going to talk about when talking about the big takeaway is this chart here. Who's seen the website businessinsider.com? Right, popular tech blog site. And businessinsider.com has a section of their website called Tech Chart of the Day. And I love Tech Chart of the Day because it's a good, reliable source of bad charts for my training courses. And so this chart came out, and I got really excited because it was just so bad. And so what we've got here is my statistics professor is happy with the title, Apple Global Revenue Share by Region and by Retail Sales. How boring. Okay, the audience here is a general tech audience on businessinsider.com. So we need the big takeaway from this chart in the title. Any ideas what the big takeaway in this chart is? What's something interesting happening in this data?
China is growing.
Exactly, the China story. Greater China is increasing in importance as a share of Apple's global revenue. So that's going to be our big takeaway. Okay, but I'm not just going to slap that big takeaway on this chart, because this chart is making my generalized anxiety disorder kind of flare up a little bit. So I need to actually redesign this chart. Okay, so as we go through this presentation, I'm going to make over this chart, but we'll come back to that. Okay, so that was the audience. Let's move on to the visuals. Let's get to the juicy stuff. When talking about the visuals, we have to make our design decisions based on what the science says. What the science says about how humans perceive the world around them. A lot of visualization best practices stem from this research from William Cleveland and Robert McGill, who were two statisticians at Bell Laboratories in the 1980s. And these statisticians came up with this ranking of what they called elementary perceptual tasks. And we're going to take a look at each one of these. So the first thing, they ran an experiment on 51 humans. And they asked the humans, they showed them axes like this with 2 points, and they asked the humans which dot is higher. And of course, the humans are very good at this. Okay, but then they were asked, well, what is the magnitude of the difference? And what is the percentage difference? And they studied the rate of error. So the humans would guess the magnitude difference, and then they'd compare that to the actual quantitative difference. And what Cleveland and McGill found is that when comparing positions on a common scale, humans are very good at this task. We are just excellent at that. Now, when the scales are not aligned, so this time we've put the second dot on a different axis, and the axis starts at a different point, and then they repeated the experiment. And guess what? Accuracy went down a little bit. Okay, it makes sense. So when comparing positions on non-aligned scales, we're not so accurate. Now, when comparing lengths, we're pretty good at this. Okay, when I compare my height to my brother's height, he's 6'3", he got the tall gene. When I compare my height to my brother's height, we stand back to back on the same baseline. And humans are very good at doing those comparisons. Now, when it comes to comparing lengths on non-aligned scales, though, we're not so good. So if I stand on this ledge, and then my brother stands on flat ground, and we try to compare our heights, everyone in the room is going to have trouble trying to figure out who's taller. Okay, so when we compare lengths on non-aligned scales, we're not so accurate. And going back to this abomination, that's why this chart performs so poorly. The subject of the story is China, but this chart is effectively asking us to compare lengths on a non-solid baseline. And based on Cleveland and McGill's research, humans are not good at that. So we want to go to a different chart that is not comparing lengths on a non-common baseline. We want to go to a different chart that is comparing position on a common scale or lengths on a common scale. Now, what we're going to see in a moment is that the line chart does this very well. If we switch to a line chart is effectively a series of points being compared on the same axis or on the same scale. So we'll switch to a line chart. The problem is, if we switch to a line chart here, we run into a problem I call the spaghetti line chart problem. Too many noodles crisscrossing, and they become hard to follow. Okay, but we're going to deal with that problem later on in the session. Okay, so we're okay at comparing positions on a common scale, and we're okay at comparing lengths. We're not so good at comparing areas, unfortunately. That's what their research found. Okay, as a group, let's try to rank these pie slices from largest to smallest. Can anyone call out, what's the largest slice here? Okay, I heard green and I heard yellow. Okay, what is the smallest slice here? Someone said orange and someone said red. And someone said they're equal. Okay, let's try this again. What's the largest number here? 4. We got it straight away. And what's the smallest? 5, right? Well, we still struggled a little bit, but generally I think we performed a lot better when these numbers were encoded as lengths rather than encoded as areas. So humans do a bad job at doing comparisons of area. But that's what the pie chart does. Okay, so things aren't looking so good for the pie based on the science. This led to a few quotes from some thought leaders that I'll just cover. Edward Tufte, the godfather of modern data visualization theory, says the only thing worse than a pie chart is several of them. Okay, and it's based on the science. Okay, comparing volumes. We're terrible at comparing volumes. Let's take a look at this pie chart over here. Who votes that item C is bigger than item A, based on your perception? Any votes? Okay, who votes that item C and item A are the same size? Okay, a few votes. Who votes that item A is between 1 and 2 times bigger than item C? Thank you. And who votes that item A is more than 2 times bigger than item C? 1, 2 votes. Outliers. Outliers who were correct. Item A is more than 2 times bigger than item C. Only 2 people in the room voted in that direction. So isn't this such an ineffective graph? Okay, the whole point of visualization is to show the data. Okay, so going back to this chart, we decided that the line chart is the way to go. Now, in every market we train in, there's a different visualization culture. In Asia, the culture is the label everything culture. Okay, and we see that being used here. So even though we've gone to a more appropriate chart, what we need to do now is clean this thing up. Okay, we'll come back to that. We need a bit more theory and science before we do that. We want some methods. We want some scientific backing for making our design choices. Okay, so I turn to this quote from Edward Tufte, who says, above all else, show the data. Okay, Tufte is the godfather of modern data viz theory. He's a statistician who almost single-handedly brought data visualization up into being a sub-branch of statistics with its own academic journals. And the quote that he harps on about is, above all else, show the data. And as a young data scientist, I first heard that quote and I thought to myself, well, all of my charts show the data. But the more I read his work, the more I realized my charts did not show the data as well as they could. Edward Tufte invented a formula known as the data-to-ink ratio. The data-to-ink ratio is a way of thinking about the cleanliness of the design of your charts. It's equal to the amount of ink devoted to the data, that's the necessary ink, divided by the total ink used to print the graphic. And that consists, the total ink is the necessary ink plus the unnecessary ink. Any ideas what the highest possible data ink ratio is?
1.
Yeah, exactly, 1. That's when your data ink is equal to the total ink. Now, how is the data ink ratio of this chart? Well, there's a lot of ink we can actually remove. Because we've labeled every line, the y-axis and grid lines actually serve no function at all. The whole point of a y-axis and grid lines is to be able to follow, to take a point, and the grid line assists you in figuring out the magnitude of that point. But if we've labeled every single line, then why do we need the y-axis and grid lines? So what we have to do is remove all of the redundancy from this chart. So we're actually going to get rid of the grid lines, and we're going to get rid of some of the other things in a moment. The other thing we're going to do is clean up the labels on the chart. And to clean up the labels, I'm going to draw on some research from these 3 German psychologists. And these 3 German psychologists came up with what came to be known as the Gestalt laws of visual perception. And what they noticed is that humans perceive the world around them as wholes rather than parts. And we're going to use this research to fix our labels on our chart here. See, Microsoft has decided that in Excel at least, you get 4 options for the spatial placement of your labels, or your legend, sorry. Your legend can go at the bottom, at the top, on the left, or on the right. And all 4 locations are terrible. Okay, so let's look at the research why. The first Gestalt law we're going to cover is the Gestalt law of proximity. Looking at these dots on the screen, some people see columns and some people see rows. Hands up if you see columns instead of rows. Yeah, most people. Okay, most people see columns because the spatial proximity on a column basis is closer than the spatial proximity of the dots on a row basis. So things that are close are seen as being together, and that causes you to see that whole column as a whole. Okay, changing the proximity now, same number of dots, and now you see rows instead of columns, again because of proximity. The other Gestalt law we're going to use is the Gestalt law of similarity. Now I'm holding the proximity of the dots the same on a row basis and a column basis, and yet you all see columns. And now I switch the colors and you see rows. So things that are colored the same are seen as being together. And the interesting thing about this is it happens instantly. You don't have to consciously think, I'm going to make myself see rows. It happens instantly. And we want to tap into that instant cognitive processing with our charts. So going back to this abomination, now I'm going to make over the chart and it's going to look like this. Why wouldn't we just put the label right next to the line? What a revolutionary idea. Okay, so now we're using the Gestalt law of proximity and the Gestalt law of similarity to tie the label to the line. Our story was about the rise of China in importance, so our storytelling title now says, Greater China is on track to become Apple's largest market by 2017. Okay? I also improved the data ink ratio of this chart. Gone are the y-axes, gone are the grid lines. And I've decided to be selective with labels because I've decided for this particular audience, they're probably just most interested in the percentages in the last year or quarter. It's up to you as the storyteller to decide how many labels you want to add. Now, the other situation where I use the Gestalt law of similarity is with my dual-axis charts, or with my combo charts. The big problem with dual-axis charts is they require quite a high amount of cognitive processing to figure out. You've got to look at the good old Excel legend down here, and then tie that to the chart, and then hold that in your short-term memory and go, okay, which y-axis does that correspond to? Okay, now I'm going to look at the other legend, and it's a lot of cognitive processing. So why wouldn't we just color the axis the same color as the series that it refers to? And that forms an instant connection between each respective data series and the y-axis that it corresponds to. Okay, the last Gestalt law we're going to cover is the Gestalt law of enclosure. What the Gestalt researchers found is that things that are enclosed together are seen as being together. So we see these 5 circles in this box here as being together, and we see the 5 circles in the translucent oval as also being together. Enclosures work really well with line charts and scatter plots. I found this visualization on Twitter from Twitter user Chap Mangamo, and the tweet that he had along with this chart was, people say data analysis is boring, but you can calculate the exact moment that Robert De Niro stopped caring. And enclosure works beautifully to tell this story. An upper blue rectangular enclosure says these were the good years of Robert De Niro, and then it suddenly drops into the lower red enclosure. Now, what if you said, actually, Robert De Niro didn't suddenly get bad? What if you said, actually, Robert De Niro has always been getting bad? What enclosure would you use then? Well, then you could use a downward linear enclosure. Now we're saying he slowly but surely got bad in a linear fashion with a confidence interval. Okay, so it's up to you as the storyteller to decide what enclosure you want to use for the job. I mean, you could have even gone with an upside down U-shape enclosure. Then you're saying he started out inconsistent, then he peaked, and then it was the slow decline of Robert De Niro. Okay, now let's go to the last key, the narrative. Here I've got, this is an obviously bad chart. It's real data. This is handset sales for the top 3 phone manufacturers. And let's make over this chart together. The first thing we've got to do is really reduce clutter and improve the data inc ratio. So I've gotten rid of the excessive labels and grid lines. Okay, but this is still an Excel special. We still have to improve this. So the x-axis label for time I've improved. And I've removed all of the junk now, and we've used the Gestalt law of similarity and proximity on the line labels. We've added storytelling. And one thing you may decide to do with your line charts is a staged story. So on first click, we're just going to talk about Steve Jobs introducing the iPhone in 2007. Click again. The successor to the original iPhone, the iPhone 3G, was released in 2008. And we're being selective with color. Because there's a lot going on in this chart. And I see a lot of data analysts and data scientists try to get everything on one slide. And that's like taking your favorite novel and trying to fit it onto one page. You just can't do it. So with a complex story like this, you've got to give justification to each movement. And then we could talk about, for example, the rise of Samsung. Okay, and they were able to capture so much market share in their first few years on the power of the Galaxy S2. So selective coloring can be really, really powerful. Okay, so those were the 4 keys to data storytelling. We covered audience. I conveniently skipped over the data because in a short session like this, it's a bit of a dry topic, and we couldn't hope to cover it in a short session like this. Then there's the visuals. We have to select the right chart for the job and then design it well. And then we have to layer our narrative on top and stage our story where possible. Okay. Now, if any of you are interested in learning these skills in more detail, we are offering our 2-day data storytelling course in Singapore next year on March 1 and 2 at the Royal Scots on Plaza Hotel. So I'll be coming back to Singapore to deliver that course, and I'd love to see you all there. Okay, are there any questions? Yes?
Question. So now let's talk about the scenario. So one is storytelling when you are just presenting something, some numbers, some stats to the known folks, right? How about a business case, right? For example, I'm from a telecom domain industry.
Yeah.
And what we need to do mostly, that we need to convince the other communication providers in UK. I'm from British Telecom. So because British Telecom has kind of monopoly, the way people say is right. So if I need to convince Sky or TalkTalk or say Virgin, right, I need to say something which they can connect with, and they have already the perception that we are not doing a favor to them.
Okay.
So in such cases, what would be your strategy? How you will present? Because this time you are not presenting someone whom you know, whom you can convince. Here, the presentation is more towards your odds.
You're saying, how do you present to someone who has already decided they aren't going to agree with you? I wouldn't really change my design process that much. I would decide what is the most important thing for them to know, and I would be selecting visuals and coloring them in a way that made the most important takeaways, i.e. the takeaways that are hopefully going to change their mind, pop out and be obvious. Yeah, I wouldn't be really changing my design process that much.
Storytelling strategy. I mean, the key part, the way I'm seeing it is more on narration.
Yeah.
No matter what you have, the way you narrate it, isn't it? I mean,
Yeah.
So, how the narration should go? I mean, would you like the narration first and then the visuals, or the visuals first?
Oh, okay. Well, when presenting to the C-level, I guess now we're talking about the chronological ordering of a data story. Now, we have to decide, are we talking about an exploring data story or an explaining data story? So with dashboards, we're talking about a spatial layout. But let's just talk about the PowerPoint deck. You've got a few options here. The general analytics deck starts title, agenda, some sort of context, overview metrics, then you deep dive into various cuts of the data, and then you lead into actionable recommendations. Now, we had McKinsey take our course, and we used to recommend that we followed that order, and McKinsey said, well, we don't do it like that at all. We go title, agenda, McKinsey statement that says, overall, we have found X, Y, Z, and then here is the data to back up what we've said on slide number 3. So if you have someone who is time poor, or someone that wants you to get to the point, I do recommend moving it forward to slide number 3 or 4. Yeah, okay, thank you. Any other questions? Yes.
So I think the way you presented it, it feels that it requires a lot of customization. So you look at it, there's all these tools and techniques. Is there any hope for doing good visualizations automatically through visualization tools that there are today? What's your opinion?
Yeah, I've heard of a few startups that are working on this. I guess we need to train machines to be able to figure out the audience and figure out what should be highlighted. For me, there's a few stages on the journey towards full automation. The first stage is we need our BI tools to just create good visuals, and we're not there right now. I hope I'm not stepping on anyone's toes in here, but in my opinion, we're not there. So we need just good data inc ratio, clean charts. Okay, so our BI tools need to get there first. Then after that, one thing I've been kicking around, and I've been talking to a few VC people about, is you create your chart, and then it automatically creates 20 different charts where different things are highlighted. And so a human can look at that and go, okay, that's the chart I'm going to use because it's emphasizing that particular line. And then really quickly, you've got something you can use and present to management, and it's already highlighting some of the parts of the chart. So yeah, I think that I think asking whether we can automate this is almost like asking if we can eventually automate the writing of a Shakespearean play. I just don't think we will get there for a long, long time. But we can certainly do a lot better on creating tools that create good visualizations and tools that make it faster to get to the point where whatever's in your brain in terms of what you want to emphasize, the tool can kind of translate that quicker. Because right now, how it is, I've got to go, if I'm in Excel, I've got to change Calibri to Arial, and I've got to change the colors and all of that. And there's some other tools out there that are further along. I think we've just got to kind of just make the tools better first, and then we can think about the machine learning part. Yeah, thank you. Any other questions? Yes?
Are there any differences in your approach when you shift from static charts that you had here and to dashboards or interactive charts?
Yeah, absolutely. Yeah. There are some situations where this approach that I've just covered doesn't work. So this approach of graying out certain lines and using color to focus on one, we trained the Asian Development Bank last week, and someone said, look, we can't gray out Kazakhstan because the diplomat from Kazakhstan is going to say, why did we get grayed out, right? So in some situations, it's much better to leverage interactivity to get around the problem of chart complexity. So if I've got a line chart with 12 different countries, it can be better to actually gray everything out and then invite the user to interact with your chart and select the ones that they think should be selected. Interactivity, I think, is an incredible tool for telling stories with data. I didn't cover it in this session, but yeah. Did that answer the question? Or? Yeah, okay, thanks. Okay, I think we've got time for a few more. Okay, great. Well, thanks a lot, and thanks for listening.